Okay, so let's talk about logarithms quick. So let's see. First things first. Let's recall what a logarithm is.
It's like it reminds me of exponent.
10 to the x.
Yeah, so it should go in your head with exponential functions, right? So you might think to yourself, like, okay, let me say y is 10 to the x, right? So this is me kind of thinking, like 10 to the x is my exponential function, right? And y is the output.
Okay.
You guys with me on that?
Yeah.
So I'm kind of thinking bubbly 10 to the stuff function, right? This takes x's and outputs y's. You guys with me on this?
Yes.
Okay, what's a picture of this function look like?
10 to the x.
It looks like a 10 to the x. Good. It looks like this, right? What's this point right here?
Y-intercept.
Uno.
That's 0, comma 1.
And it never touches the x-axis.
And yeah, it never goes into the x-axis. So, question, does that pass the horizontal line test?
Yes.
Yeah, it totally does, right? So, what?
It has an inverse,
So there's some inverse, right?
which is a log base 10.
So there should be a way to go this way, right? And I'm literally just going to give that thing a name.
Call it a logarithm.
I'm going to call it a logarithm.
No obvious reason as to why that is.
Yeah, fair point.
Logs.
I actually just realized that I don't know why that is.
Right on.
Apparently, I've never asked myself why that word.
Yeah, what's the logarithm?
I don't know. Okay, so on the flip side, right, what would the kind of equation speak for that be?
So you get your y.
Take your y, right,
And you get an x.
and do
Log 2.
log to it, and you get x, right?
Yeah.
You guys with me on that? So this side over here is pretty often called exponential form, right? Where you're living with an exponential function's inputs and outputs, right? If you think about the other way, what's over here? What would you call this form?
Log form.
Log 4.
Yeah, you would call this log form.
For obvious reasons.
For the for an obvious reason, once you knew why they named it a logarithm. Please do. Okay, so this is the base 10 one,
Yes.
right? So it should be noted that this guy here, the log with no decorations, think tens. If I did this with e's, I'd have y as e to the x,
It's a different
Alright.
number.
and I'd think e to the stuff is my function, and the backwards direction is
Is that true? Oh.
natural log,
When they call it something.
as opposed to the unnatural logarithm, which is something else.
Log form.
Is there actually something called the unnatural logarithm?
No.
Okay, just making sure.
There's an obvious candidate for that. We can talk about it. Log of what?
Why?
Y should be
X.
x.
The unnatural logarithm is the root.
You guys call that? And when you see an ln, you think to yourself e.
E.
Okay. And then if we had a different number in the base, like say we had y is b to the x, I'm going to trust that you guys could kind of think about filling in the bubble diagram yourself. What would your logarithmic form for this guy be? Yeah, so you'd probably say something like log y is x, right? Except you need to know which base you're talking about.
Base B.
This one right now is log base
10.
10. You want log base b. So we have this habit of writing a little b down there.
Because you don't need to write log base 10. You just assumed.
Yeah, and because I use the log base 10 all the time, I'm going to assume that one, if I don't write a base, it's 10. So why 10?
Because it's an
So you
exponential.
transition between the metric system as well.
Kind of, yeah.
Yeah.
So why is 10 the good one?
Because powers of 10 are really easy
Powers
to
of 10
work
are
with.
awesome.
Because you have 10
You have
fingers.
10 fingers.
No.
Yeah.
Ah.
Really?
Yeah.
That's so.
Yeah, really.
shallow.
There's not actually a good reason for the base 10 system other than you happen to have 10
Dude,
fingers
if
and
I had
toes.
11 fingers, I'd still vote for 10.
10 is also a convenient, it's a convenient base in that it has a number of kind of numerical tricks.
Right.
You guys know, like, a trick to figure out if something's divisible by 3?
Cube it.
No.
If its last number is
No, I think it's the sum of the last two numbers. No?
Dude, cool. None of you know this trick. Okay, so one of the reasons for base 10 is that it has a bunch of tricks of the form, is this number divisible by this other number? Like, in this case, is this number divisible by 3? The way you figure out if a number is divisible by 3 is you add up all its digits, and if that's a multiple of 3,
Yeah.
right? So if you want to figure out if 187,612 is divisible by 3,
You add up each individual.
add all the digits, so I get 9, 16, 22,
Oh, no, it's not 25.
21, 25.
25.
25 divisible by 3.
No.
Now, this is not divisible by 3.
What if you add up all the digits and it's another number that's like super huge?
Then add them again.
You can do that like over
Yeah,
and over again?
yeah, you can stack that trick.
That's crazy. Or you just
Cool.
plug in
So,
calculator by the-
that's one good reason for base 10. That's gone a little bit by the wayside, right? Because if you guys want to find out if 187,612 is divisible by 3, what are you going to do?
Calculator, get my calculator.
Yeah, get a calculator. Before the advent of calculators, base 10 was really nice because those tricks were available, right? So if I had asked this question in a pre-calculus class in 1912, every single student would have been like, just add up the digits. Because they would all use that trick all the time. Cool? All right, so these are exponential form and logarithmic form, yes? Okay, what do the graphs of the logarithms look like?
Cool.
The inverse. I'm going to say reflected across the. Is it?
Oh, do you guys not know this trick? Okay.
Yeah.